On a recent video, I got this question from a viewer. Could you help with code that accepts only integers as input? And I think I know what they're talking about here. In C, it's not as easy as we might hope to only accept integers as input. So that's the problem we're going to solve in this video. We're going to figure out how to reliably accept integers as input using C. So the first thing I want to show you is why it's not so easy to accept only integers as input using C. We'll make an int variable called integer, and we'll initialize it to 0. But then we'll try to use scanf to actually accept integer input. So we'll say printf enter integer, and then we'll say scanf %d, and then and integer to store the value that's entered into the integer variable. And then we'll try to print it out. We'll say printf integer %d \n, and we'll output integer. And if I save and run this, it'll work fine so long as we use the expected values. If we use 12, we get 12. If I say here -12, we get -12. That's okay. But if I try other things, like let's say ABC, I get 0. If I try something like 123.45, I get 123. So scanf doesn't seem to reliably detect when something is not really an integer. It sort of does the best job it can. In the case of a string, it left integer as 0. In the case of a floating point value like 123.45, it was returning 123, the integer portion of the number. So scanf is not as reliable as we might hope. So one thing we can do with scanf is that scanf will return the number of arguments in this list here that it was able to read successfully. So in this case here, we have 1. So we could check. We could say if scanf returns 1, then we'll print out the integer. Otherwise, we'll printf integer was not entered correctly. And we can save this and give it a try. And now if we enter in ABC, we get integer was not entered correctly. So scanf is at least helping us with that. But if we run it again and type in 123.45, we're getting integer 123. So scanf can help a little bit in terms of helping us detect that an integer was not actually entered. But even in the case of this floating point value here, it's not really doing what we want. Really, that's not an integer. We would want to tell the user again, hey, you need to enter an integer. That is not an integer. So how can we do this in a more sophisticated way? How can we make sure that the input we got from the user is going to be an integer? It turns out this is going to be quite involved. We're going to have to do some of our own input validation to make sure what was entered is actually an integer. So that's what we'll do. And it won't be easy, but we'll do it. So the first thing we'll do is actually include a few libraries to help us. We're going to include the C-type library because that has functions that allow us to detect whether we've got a space or a digit and things like that. We'll also include stdlib.h because this library includes a function, atoi, that will allow us to take a string and convert it to an integer. We'll also include string.h because this library includes helpful functions for working with strings, including a string length function to find the length of a string. And we'll include stdbool.h, so we can use bool types made up of true and false values. Now we'll make a function that's actually going to take a string and parse it and ensure that an integer is present in that string. And only if we've correctly identified an integer contained in that string will we take it and convert it to an actual int value. And that's how we're going to do this. We're going to actually first validate that what was entered was in fact an integer before we attempt to convert it to an integer. And we'll make a function to do this conversion for us. We'll say here bool parse int char star string and int star integer. So the function is going to accept the string as an argument, and it's going to return true if we were successful in reading an integer from the string, and false otherwise. And the actual integer itself is going to be returned using pass by pointer here. and it'll be saved in the integer variable that is pointed to by this integer pointer here. So we'll copy this and we'll paste it down here, and we'll provide our definition of the function. Now we're going to assume that this function is being called after input has been accepted from the user, after say fgets has been used to read a string of input from the user. And we're going to assume that that string has been stored into this string here. Now what we'll do is accept integer strings if they have spaces around the integer. So we could have a number like 45, but if there's white space characters in front of that number or behind it, we're going to say that's okay. And by white space, we mean space characters, new lines, tabs, that kind of thing. But anything else, we won't accept. So 45.2, we're going to say that is not an integer. If there's a 45 and then followed by that, an A, we're going to say that's not okay. If there's an integer here, like 52, and then behind it here, there's a float like 12.12, that's not okay either. We specifically want an integer. And if there's white space in front of it and after it, that's okay. But anything else at all is not okay. We'll also accept integers that are negative. So something like negative 52, we would accept. And we'll also accept things like this. If we have something like negative 0.0001, we would say that's actually okay. And that's kind of a weird way of writing -1, but we will actually parse that and treat that correctly as being -1. So what we're going to do is first move through the white space characters that are potentially at the front of our string. So to do that, we'll make a counter variable I. We'll say int I is equal to 0. And I is basically going to keep track of our position in this string throughout this function here. And we could actually make a little mock string here. We could say comment here. We'll say there's some white space characters here. Those are going to represent white space characters. And then we'll have an integer here like 52. And then we'll assume there might be some white space characters at the end. So maybe some spaces and maybe a new line even. So the first thing we got to do is move through these white space characters to get to the integer here. So to do that, we'll say while is space string at index I++. And what this will do is just keep on incrementing I so long as is space is returning true for the character in the string at index I. So we're looking at one character at a time in this string. And so long as is space returns true, we're going to continue to increment I. We're going to stop this when we find the first character that is not a white space character. And that could even be the null terminator. So remember, all strings in C are terminated with a null terminator, which we represent with \0. So even if the first character it encounters that is not a white space character is the null terminator, this will still work. Now what we're going to check for first is if we've reached the end of the string. So to do that, we're going to say here, int length is equal to strlen, and we're going to say string. So strlen is going to return the length of the string, not including the special null terminator. And we're going to check to see if I has reached the end of the string. If it has, then we just had a essentially blank string with all white space characters. Because this is space function that's coming from the C-type library is going to return true if this character here is a blank space or a new line or a tab or certain other white space characters we call them. So it's possible the while loop just keeps on incrementing I until we hit the null terminator. And we could check to see if we reach the end of the string by checking if I is equal to the string length. And we can just return false in that case. So the next thing we'll have to do is actually start to read in the integer. We're going to read in all the integer characters up until we encounter either white space or the null terminator, the end of the string. And we're going to take those characters and store them in a buffer. And then we'll convert the integer stored in that buffer into the actual int value that we want to return by pass by pointer. So the first thing we're going to check for is the dash character. So it is possible the integer is negative. And we'll just kind of get that character out of the way, because after we've checked for that character, we can just check for subsequent digits, like 0 to 9. So the first thing we'll do is make our buffer, which is going to be a character array where we're going to store the integer that we extract. So we'll say here car integer buffer. And let's actually use a constant for the size of the buffer. So up here we could say number define buffer size, and make it very large. We'll say 4096. And then down here we can say buffer size. And this is the character array where we're going to store the actual string representation of the integer that we're going to extract from the string here. We'll make an integer variable to actually keep track of the number of characters stored into integer buffer. So here we'll say int integer cars is equal to 0. Because we're going to have to keep track of our position in this integer buffer as we take each integer character from the string and store it in this buffer. So the first thing we'll do is try to detect a potential minus character here for a negative number. So we'll say if the string at index I, because remember we left off at index I, that's where we stopped. So if the string at index I is equal to the minus character, then we're going to take that character and store it into the integer buffer. So we'll say integer buffer at integer cars index is equal to, and we'll just store the minus character. And then we'll say integer cars plus plus and I plus plus. So we've basically processed one more character of the string. And we've taken that minus and we've now stored it into our integer buffer. So our buffer would now look like this. In our integer buffer, we now have just the minus character there. And we have I keeping track of our index into this string here. And we have the integer cars variable keeping track of our index into this buffer here. Now the next thing we're going to want to do is read in the digits that should come after the minus, if there was one. But the first thing we'll do is make sure in the case of a minus character, that there actually is at least one digit afterwards. Because we can't have just something like this, where we just have a minus character here. That's not going to work. That's not really an integer, right? There has to be at least one digit afterwards, even if it's a 0 or something like that. So we'll check here using the isDigit function that also comes with the C-type library. And if the next character is not a digit, then we have a problem. And we're going to return false because we don't have a valid integer in our string. So the next thing we've got is a sequence of digits. And what we want to do is read those digits into the integer buffer, potentially after that minus character. So we should end up with this, 52. What we'll do is make a loop. So we'll say here, while I is less than length and not is space string at index I. And in the while loop, we're going to increment I. So we're going to keep on looping through our string one character at a time until we either reach the end of the string or we reach a white space character. And we're going to look at each character. And if that character is not a digit, then we have an invalid string. We don't have an integer in our string. And in that case, we're going to return false. If it is a digit we've got next, we're going to store it into the integer buffer. We'll say integer buffer at integer cars is equal to the string at index I. And then here, we're going to increment integer cars. So basically what we're doing here is continually copying from our string here into our integer buffer until we either reach the end of the string or white space characters. And if we encounter something that's not a digit, not white space, and not the end of the string, then we're going to return false. So at this point here, we'll have actually copied the characters of the integer into the integer buffer character array. The last thing we'll do is put a null terminator onto the end of that character array to make it a actual string in C. So we'll say integer buffer at the integer cars index and set it equal to the null terminator to properly end the string. Now the last thing we're going to want to do is loop through any potential trailing white space after the integer. So we'll do something very similar to what we did up at the top of the function. We'll say while is space string at index I++. So loop through any of the trailing white space characters, whether they're spaces, new lines, or whatever. Now at this point, we really should be at the end of the string. And we're going to check for that. We're going to say if string at index I doesn't equal the null terminator that signifies the end of the string, we're going to return false. Because if there's more to go after doing this, then our string is not correctly formatted. And then finally, we can actually convert the integer value. So here we're going to say star integer is equal to ATOI and then integer buffer. So the ATOI function is going to take this string representation of an integer. It's going to make it an actual integer value, and it's going to return that. And here we're dereferencing the integer pointer parameter here. And we're going to go and set the actual variable pointed to by that pointer by dereferencing integer here. And at this point, we know that we've successfully obtained the integer, so we can return true. So that was quite a bit. Let's actually try to test this function out now. Let's scroll up here. And again, we'll ask the user to enter an integer. But this time we'll do it in a do while loop. We'll say do, and then while. And first we'll prompt the user. We'll say printf enter integer. And instead of using scanf, we're going to take what the user enters and we're going to store it into a character array buffer as a string. So we'll say car buffer, and we'll use the constant buffer size again. And now we'll use fgets instead of scanf. So we'll say fgets buffer size stdin. So what fgets is going to do is read from standard in. In other words, the terminal or console in most cases. And we're going to store the characters entered into the buffer character array up to buffer size amount of characters. Now we can actually call the function with this string that's stored in buffer. We'll make a bool variable called parsed correct to actually keep track of whether the value was parsed correctly or not. So we'll say bool parsed correct is equal to true. And then we'll say parsed correct is equal to parse int, and we'll call it with the buffer, and we'll pass in the memory address of integer. So that's going to be our pointer there. We're passing in a pointer, a memory address to this integer variable here, and that's where the successfully parsed integer will be stored. Now, if it can't be done, we know parse correct is going to be false. So if there was a problem, we're going to say if not parsed correct, then printf must be an integer value. And we'll warn the user, followed by a \n. And we're going to keep doing this so long as it is the case that we haven't parsed correctly yet. And then finally, when we're done, we'll print out the integer. We'll say printf integer %d\n, and we'll output the integer. And we'll save this. And now we'll try to test it out. So we'll run it, we get build succeeded, and we can try it out. If I put 5 here, it seems to work. We get integer 5. We'll try to run it again. I'll try -26. And again, it seems to work. Let's try some harder cases now. Let's put some white space in front of our integer. So we'll say space, 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 and then 45. And we get 45. So it seems to work. Let's try to put some white space at the front and end of our integer. So some spaces here, maybe 57, some more spaces, and we'll hit enter. And again, it seems to work. We'll try it with some negative values and some white space. So we'll run it again. We'll say space, 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 -22, space, 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 hit enter. We get -22. Now let's try some invalid strings. So strings that do not contain an integer potentially surrounded by white space, which is what we're saying is okay. So let's try out 12.5. We're going to say that is not an integer. We consider that to be a floating point value, and we want our function to not validate that. We want it to return false instead. So if we hit enter, we get must be an integer value, and we're asked to enter something again. Let's try to put some spaces in front. So spaces, maybe 14.32, and hit enter. Again, must be an integer value. Let's put spaces in front of and behind a floating point value. So we'll say space, 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 -56.12, and some spaces behind it. And again, must be an integer value. So it seems to be handling that case okay. Let's try to put some characters like ABC. We'll say space, 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 ABC, space, space, space. Again, must be an integer value. Let's try to put some characters after a valid integer. So let's just say we have 23 and then a bunch of spaces and then A. That's not valid, must be an integer value. Let's try to put 2 valid integers. So an integer followed by an integer. Our function should say that's invalid because it's not really an integer, it's 2 integers. So we'll say space, 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 56, space, 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 12. Must be an integer value. So we could keep testing our function out, but at this point we're confident that it works. So this is how we could reliably accept and validate integer input in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.